Question 3. We've got a cubic sketched and there's a bit of information shown. We've got an inflection point that looks like it's on the y-axis and a minimum located at 1, 0. And the shaded area is 3/2, 1.5. So there's not much to this question. It's 7 marks and we've just got to work out what A, B, C and D is. In other words, find the equation of the cubic. So the strategy in this type of question is always, or very usually, to start off with the second derivative, just because it eliminates C and D, and having 4 unknowns is a bit of a nightmare. If we can get it down to 1 or 2, then we're ready to go. So that's the first thing I've done here, is to differentiate the function and then get the second derivative out here. So then we can use the fact that we've got the second derivative is 0 when x is 0, using the fact that when x is 0 we've got an inflection point. So when we substitute into this equation, the x term disappears, so we're left with 2b is equal to 0, and therefore b must be 0. So we're already sort of well on our way. We've got one of the values and eliminated an unknown from the equation. So here we go. So now, using the fact that we've got a stationary point at 1, 0, so we know then the first derivative is equal to 0 when x is equal to 1. So we're going to use this equation and substitute in the fact that x is 1, we end up with 3a plus c, remembering that b is 0, is equal to 0. And so we can work out that c is equal to negative 3a. And then the last thing we need to use is the fact that we've got the point 1, 0 here. And so we can substitute that into the original equation and get that a minus 3a, which is c, plus d, must also be 0. 0 from the y coordinate here at this point. And therefore, from this, we can rearrange it and get that d is equal to 2a. So once we've got that far, then we can set up the next equation using the area. We write the integral, so we've got the polynomial here purely in terms of a's and x's, and we know that if we integrate from 0 to 1, then we've got to end up with 3/2, which is 6/4. So the next job is to get this integral done. So here it is, and then we substitute in the values of 0 and 1 for x. That gives us this equation, and on the way through I've decided to put everything over 4 just to make the sort of arithmetic easier when we have to add the tops here. So we can see when we tidy up the top here, we end up with 3a must be equal to 6, so therefore a is 2. And once we know that a is 2, we can use the fact that c is negative 3a, so c must be negative 6. D is equal to 2a, so that means d must be 4. We already worked out that b is 0 and a is 2. So a nice 7 marks, and I'm sure the students would have gone pretty well on this fella.